All right, welcome back to day 2, where we're going to look at measure of spread. Yesterday we looked at measure of center. Today, same mean, different story. So to introduce this, we're going to look at these 2 class periods, class period 1, class period 2. They have different test scores. So I didn't have y'all do this, or I didn't specify this on the video, but what you should be doing, and we can delete these later, but just since we already made the calculation, we want to make a practice sheet so we can do our delta math, because it makes no sense on doing this, and I don't want to mess up our sheet. So let me show y'all like one way that we can do that. Not this. No. Yeah. Okay. Come on. All right. Let's okay. So what I would do is, like, we can do this a couple times. This is really just to kind of get a quick practice look, and so we can mess things up. So over here, I'm going to go down to the bottom where it says heights, and I'm just going to duplicate this page. Why am I going to duplicate this? Well, so I can not mess up this height stuff. I can do like practice, and each day we might want to do this because we're going to add stuff to it, and that way we don't have to do a whole bunch of useless stuff. So now I don't really care about, well, I can do something like this. So here in my practice, like, I can say that this is, I can go through and I can delete these and delete these, and we can, and I don't even need to rename these, but like this boys, I can pretend is class period 1. This girls, I can say is class period 2. And I can go up here at the top and say, okay, that's 76, 78, 79, 79, 80, 80, 81, 82, 82, 83. And those are my class period 1 grades. Over here I have 55, 60, 65, 70, 85, 85, 90, 95, 95, 100. Okay. So I have all of those in there, and now I'm not comparing both. This the mean and median for boys, or for this group, came from this column. The other one came from this column. And then both of them came to this, but I don't really care about that because I'm not asking you for anything with both. Okay, so let's look at, let's just pretend the one on the left is the class period 1 and class period 2 is the one on the right. So use your practice sheet to calculate the mean for both class periods. So we're looking at the mean. They're both the same, right? We can see those are the same, but the median is different. And why might the median be different? So, I mean, they have the same average. I'm not asking you which one's the better center here, but let's see. Get lost going back between both of these sheets. So statistically, based on the mean alone, these classes look the same. But if we forget the mean for a second, let's just look at the scores themselves. So here I can see, for one, the lowest score in period 2 is a 50. 55, sorry, and the highest is 100. Class period 1 doesn't have really anything close to 100. They have 0 A's in the whole class, but they also don't have really any failures. So they don't look the same. Like they look actually kind of like very different, but they had the same average. So what the mean doesn't tell us is like the consistency. Like if I were to ask you, what class do you think did better? Well, like I said, class period 2 had, there's only 1, 2, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 grades. And out of those 10 grades, we had 3 people fail this class, and 1 person made a 100. We also had 4 A's. The other class, we didn't have anybody fail out of the 10 people, but we had no A's, and we didn't have any really low C's either. So which class did more consistent? Does one class have more extreme values? I wouldn't really say extreme, but I would say that the one data looks more spread out than the other. Like, and hopefully we can see that. So the mean tells us where the data balances are, but not how spread out the data actually is. So if I were to ask you, which class period do you think the data is more tight versus which class period is more spread out? And hopefully we can see that class period 2 has a much larger spread than class period 1. Class period 1 is kind of clustered more tightly together. The lowest grade was a 76, the highest grade was an 83, and all the other grades are in between. On class period 2, we have a 55 as the lowest and 100, and all the other ones are in between. So describing that term spread out, we can also say things like scattered, clustered, things like that, tight, wide, so on and so forth. We need a way to measure this idea. So we're going to do that by naming it, instead of measure of center, we're going to call this measure of spread. And that's important because we look at the mean, and the mean tells us kind of that number that we're looking at that is supposed to be the typical value. But if we compare these two groups and they have the same typical value, I mean, we can use the median, sure. But like if we're talking about the mean alone, the spread is off. They're very different. So now we give that idea a name. A measure of spread is also in your notes. It's another summary statistic, which tells us how much the data is spread out or scattered or clustered or tight or wide. I don't know why those are down there. So we're going to look at some various measures of spread, and we're going to start off with the range. This is our big picture spread. This is a simple calculation. So the range is just taking the maximum number in the data set and subtracting it from the minimum number in the data set. So largest number minus smallest number, and that just tells us how big our overall spread is. Big range, the data is more spread out. Small range, data is more clustered. So why range isn't enough? Range only looks at two values, the smallest and the largest. So let's go back over here to our it ignores what's happening in the middle of the data. Before we get into that next slide, let's go over here and add a spot for the range. So we'll do that here in a second. Don't want to jump ahead. So we also kind of want to know what's happening in the middle, because that's important. So we need something better than just the range, but the range is good in terms of telling us how big the overall spread is. Thinking in groups, not individuals. So instead of focusing on individual scores, we can also divide the data into approximately equal groups. And hopefully this will make sense here in a second when we do it. This helps us to see where most of the data lives in these different intervals. So we're going to start by dividing data into what's called quartiles. And when data is ordered, we can identify our lowest value, our highest value, our middle value, and then we're going to end up splitting two values into where we have four different parts where our distribution has about approximately an even amount distribution between each one of those parts or intervals, about 25%. These split points are called quartiles. They look like this. So over here on the far left, we would have our minimum, and then this Q1 is right here. Notice 25% of the data, the smaller data values, are going to be to the left of Q1. And if to the left of Q1 is 25%, then to the right of Q1 would be 75% of the data values. The median is going to be, we're going to label the median here in the middle and not the mean. And then the third quartile is going to be in the upper 75%. So each one of these little sections, intervals, have approximately 25% of the data values in there. So we're going to look at 5 different numbers that tell the story of our distribution. Together, these values form the 5-number summary. This is a set of 5 values that describe the distribution of a data set. The 5-number summary defined is The first one being the minimum value of the data set. So we're looking at things instead of one single number, kind of a group of numbers to kind of just, it's still summarizing the big long data set, but with important numbers that matter. So the minimum value of the data set is part of the 5-number summary. The Q1 that we just saw is greater than approximately 25% of the data. Q2 is also known as the middle or the median, and we've already looked at that. It's greater than approximately 50% of the data and less than approximately 50% of the data if it's in the middle, right? That should make sense. Q3 is greater than approximately 75% of the data. And then we have the maximum, which can also be called Q4, which is the maximum value in the data set. So we're going to look at these Google Sheets formulas, and we're going to add these to our Google Sheets. So for one, the minimum, we saw this actually when we did our spreadsheet project the first time. When we looked at that movie example, that equals min will give you the smallest number in the data range. This one, so the data range is just the cells that we're going to be highlighting or clicking. That's what that means, okay? This first word is telling you what function we're going to be doing. So Q1, we're going to enter in the word quartile because we're trying to find the quartile. Then we're going to select the data range followed by the comma, and then we need to let it know what quartile we want, and that's where the number 1 is coming from. For Q2, that is the median, but however, we can also do it just like we did with the quartile, except change the number 1 to a number 2, because the median is the same thing as quartile 2. So either one's fine. We can do equals median and select the data range, or we can do equals quartile, select the data range, comma, and then put the number 2, like this. Quartile 3, we're going to do equals quartile, and that's both of those quartiles should have an equal in front of it. My bad. Select the data range, and then since this is quartile 3, we're going to put comma 3. The maximum, we're going to do equals max and then select the data range. So we're going to do some spreadsheet work time. I'm going to let you guys start on that. I'm also going to show my screen. I would try to refrain from just being so dependent on like following me exactly. Like try to get some of this stuff and understand this stuff and work ahead and then pause the video if you're watching it, if you get stuck somewhere so you can figure out what's happening. So we're going to calculate the 5-number summary from our spreadsheet. And I just want to add that to the existing thing. So right down here, yesterday we got down to all of this, right? And so what we want is we're actually going to go down, and we haven't talked about this just yet, but we might as well do it because I think we're talking about it today. But right underneath median, I want y'all to do something like this where you merge those cells together, write measure of spread, and then we're going to make y'all's look kind of like mine. I'm going to do min, Q1, median, Q3, max. Then I'm going to have a blank little thing to kind of separate my measures of spread. Range, we looked at how to calculate, and then we'll talk about this IQR stuff here in a moment. But just to make sure that we're on the same page, once you get this formatted and looking nice, you can go ahead and copy this over just like we did yesterday. Like take this, right click, hit copy, then go over here to the girls, do the same thing, and that will save you some time so you don't have to do all 3 of those. Instead of it taking 5 minutes for you to format it, it may take you 1 minute because you spend a minute and a half or something on the first thing, and then you just copy it 2 different times. You'll need to make sure the formulas are in the right column. So let's just make sure we understand this. Let me zoom in real quick. Using the formulas we just talked about, starting with minimum, that should be equal min. And then what am I finding the minimum for? Well, this is column D right here. So that's the range that I'm selecting. Quartile 1 should be equals quartile. And then I want to say I am in column D again for that one. And this is the first quartile. So I'm putting the number 1 there. I don't know what I just hit. Oh, right here, I didn't want to type the formula. Since I already had median right here, I just put equal I4, which is this cell right here. So it copies it. So like if I write this, you can also do things like this. So there's my name. If I do equals F4, it's going to put whatever I have here. So anyways, I'm going to do equals what was that? I for, or we can do equals median, select the range, and then max, we're going to do equal max. For this, we'll do quartile, select the range, and do 3 because it's quartile 3, and then max equals max, select column D. Also, we don't want to type in numbers here on a spreadsheet, right? We don't want to type in for the range. We said that's max minus min. I do not want to sit there and do equals 83 minus 76. We don't do that. We've talked about that multiple times. So what I want to do, especially since I already have a column for max and min, I'm going to select this cell right here where 83 is and do that minus this cell. So if you look at my range, it is cell I10, which is this cell right here, minus I6, which is this cell right here. That way, if my spreadsheet grows, things like that, it automatically calculates. That's the whole power of the spreadsheet to begin with, is to be able to have those formulas in there that are like ever so changing and adjusting as you add to it or change things like that. Okay, let's go back to this. So calculate the 5-number summary for our Heights data, create, format, and enter formula similar to how I have laid out in your notes. I do want you to go ahead and fill in your notes once you have those things down, just so you can have kind of a hard copy of that. And you can use that to kind of reference for your project piece. And then we'll do range here in a second. So from quartiles to spread, now that we have quartiles, we can measure how spread out the middle of the data is, because that's important. It's one of the most important parts of this. And this is called our interquartile range, or our IQR. And it's also an easy calculation, but it measures the middle 50% of the data. So not the middle, but the middle 50%. And we do that just by calculating Q3 minus Q1. So remember, that's part of our 5-number summary. So when we find out what those numbers are, we don't want to do like 55 minus 45. We want to do whatever cell 55 is in minus whatever cell 45 was in. Okay, so we're going to go through and do that. And so this is where the majority, the middle 50% of our, not the majority, but the middle 50%, which is centered around that median, which is important. So that's kind of what that looks like. A larger IQR indicates that middle values are spread out more, and a smaller IQR means that the middle values are clustered together more. This tells us where most of the data points fall. So we're going to add these both to our spreadsheet now. So calculate the range and IQR on your spreadsheet. We're going to go back to our spreadsheet, and just underneath where we did our 5-number summary, I want y'all to make a little separation between this, because this is not part of the 5-number summary, but these are also parts of spread. So we're going to write range, and then we're going to do our max minus our min. And then on IQR, we're going to do our Q3 minus our Q1. And these are cells if you look at those. Okay, they're not numbers again. Once we have those, copy and paste that thing for the girls. Make sure that your formulas are consistent. These are looking at column D. These are looking at column E. And you want to make sure that those, like, double check the cells and make sure they're doing the right ones. And then you go through and do the one for both. Okay, last bit of information for today. Recall, what is an outlier? So here is a visual of what an outlier may look like with some type of distribution. You have all these things clustered together, and then you've got this single little point out here. An outlier is any data point that lies outside the overall pattern in a distribution. These are two different visuals of what outliers may look like on a graph. Outlier rules. These are also formulas. Any data value that is greater than your Q3 value plus 1.5 times the IQR is considered an upper outlier. Okay. Any data value less than Q1 minus 1.5 times the IQR is a lower outlier. So the last thing we're going to add to our spreadsheet is this outlier upper and lower bounds thing. And then we're going to see if we have any outliers in our data set. So make sure to do this for girls, boys, and both. So let's go back to the spreadsheet. I'm just going to call this lower bound. So I'm going to leave myself a little blank between my range and IQR, just kind of separate this. I'm going to call this lower bound. This is going to be my lower bound rule. So this is giving me anything that, so this says 74.875. I'm also going to take out, I'm going to leave one decimal on those. Okay. Any height that is less than 74.9 inches would be considered an outlier. So, and I can see that the first place I would look, rather than going over to the list over here. Oh, I don't even have my, oh, I'm on my practice sheet. Okay. So anything less than 62, and any height less than 62 would be considered an outlier. Any height above 78 would be considered an outlier. And then I would list those on my project. I would say this data value is an outlier. This one was an outlier. If I had them. So the first place I would look is up here at the maximum and minimum. Notice this maximum right here is 78. My upper bound is 78. So anything greater than 78 would be considered an outlier. So I didn't have anything greater than that. That's the first place I would look. If that number was a 77 for max, then I would look to see if I had any, if this, I'm trying to think of how to word that. If I did have an outlier, I would go through and I'd look at my list and see how many I had. I would count them up. My lower bound, I would look at my minimum first. Minimum 61. Anything less than 61, well, that's 62. So we're good here. We go across the board. Oh, let me show you what it looks like. So for lower bound, remember it's Q1 minus 1.5 times the IQR. So Q1, that's in my cell I7. That's right here. And then we do minus 1.5. We type this number because that's part of the formula. We use the asterisk to represent multiplication times my IQR. Well, IQR is in cell I13. That's going to be right here. And then for my upper bound, it's quartile 3, which is in I9 right here, plus, not minus, 1.5 times the IQR again. And then I get this. Once I have those, we're going to copy all of this to where we have boys, girls, and both summary statistics. And your math needs to be consistent with all three of these. So, big picture, measure of spread. Order matters. We start with range. We divide the data into quartiles. That helps us to determine our 5-number summary because that uses quartiles. We calculate our IQR, which is the spread in the middle, and then we determine if we have any outliers that is identified by using the IQR. And that is all we have for today. You do have delta math. What I would do if you're watching this video is let's go ahead and take this. Let's delete this. We can delete this practice just so we don't have like a whole bunch of practice stuff. And since we just added some stuff, let's go up to our thing and just duplicate it. And now for our delta math, we can go here and we can zero out our boys and our girls tables like this. And now we can use these two columns, and I don't really care about this stuff. That's all I got.